Okay, hi everybody. My name is Behrad Babaee. I'm a technology evangelist in Aerospike. Aerospike is a NoSQL database company. My history with NoSQL databases is quite extensive. I've been in Aerospike for more than 2 years. Before Aerospike, I was in another NoSQL database company called DataStax. They are the main contributor to the Apache Cassandra project. Before that, I was mainly a developer. I've been using Cassandra heavily. Before that, I used Couchbase for a short stint. I used MongoDB extensively back in the day. Well, let me put it this way, that the first time that I touched NoSQL is 2010 when I developed the application on HBase. So I have a bit of a background on that. So that's a quick introduction about me. And I'm joined by Abhijit. Abhijit, do you want to give an introduction to yourself?
Absolutely. Well, thank you everyone for joining. I've it's a privilege to talk to all of you. I'm Abhijit Sunil. I'm a senior analyst with Forrester Research. I particularly work in sustainability and cover the IT decarbonization levers that various organizations, various industries undertake at this time. I've been with Forrester for over 4 years now, before which I was a researcher at McKinsey. And I am looking forward to having a discussion with Behrad on some of the recent research that he did in software sustainability, and also presenting some of the findings that we've had at Forrester on a survey that we did worldwide on the state of IT sustainability, the trends that we observed, and how and where emissions in IT come from, or within the enterprise architecture of all industries.
That's great. Thank you very much. So I want to start the conversation with setting the scene. So the title of this talk is The Role of Software in Reducing CO2 Emissions. Usually when I talk about this topic to people, the first question is that, but software is something virtual, right? You know, something virtual doesn't necessarily generate emissions and toxic waste. And for that, I have an analogy. So I want to give that so we can start the conversation. You know, we rarely talk about emissions of jet engines. We usually talk about emissions of aviation industry. We are talking about emissions of flying, right? Although it's the actually the thing that is actually generating the emissions is the jet engines. So software industry and hardware industry are kind of similar to that. You know, it's the software that is running on the hardware, and because of that, you need the hardware. If you turn off all of your software systems, you wouldn't need any hardware. And if you don't need any hardware, you can turn off all of your data centers, and you are not going to produce any emissions. So it's the driver of emissions. Of course, you know, like aviation industry, efficiency of the jet engine is important as well. You cannot just forget about that. So if we want to have an effective conversation, we have to focus on reducing the emissions on the infrastructure, you know, hardware infrastructure side, but we shouldn't forget about the efficiency of our software platforms. So I have done a bunch of research about software efficiency and effect of it on reducing carbon emissions. And as Abhijit said, he led a very done research or survey on the state of sustainability in IT organizations. And hopefully, putting our knowledge together, we are going to give you some information that you will find useful. So with that, I want to start the conversation. So Abhijit, in the beginning of your report, you define basically the time secondary sources of CO2 emission organizations. Can you explain those basically sources, so we can basically see the differences between them.
Sure. So you set the stage very well, Behrad, in talking about how sometimes we don't think about software as having carbon emissions, but it is really the underlying infrastructure that powers the sources where carbon emissions of software comes from. But if we look at the IT organization within any company as a whole, where do emissions come from? So we found in our research that emissions came from a variety of sources within the IT stack. First and foremost is the data center and cloud infrastructure of organizations. Now, data centers themselves are a big consumer of energy globally. The International Energy Agency recently published a report that said that only data centers globally consumed more than 1.3 to 1.5% of global final energy demand, which is substantial and likely to grow even further. So, in industries where data centers form a major backbone of their operations, for example, financial services, data centers are a major source of their scope 1 and scope 2 emissions as well in just a moment. But other than data centers, then are the emissions that come from end user devices of an organization's IT infrastructure that employees use at the workplace. So essentially, IT in the workplace and emissions associated with that. And then a third element, very important, is applications and the emissions that come from the software part of enterprise architecture. So the emissions that come from hosting applications to the emissions that occur during software development, all of that falls into that umbrella. And the sources from where carbon emissions come from can be then subdivided into the carbon emissions that occur when infrastructure is manufactured, to the supply chain, when infrastructure is shipped to premises, and then also at the end of life of infrastructure, the angle that we talk about in terms of circular economy and how we define those. But we just touched upon something that is a very widely used framework, scope 1, 2, 3 emissions. And I'd like to take a moment to define what those are. In any organization, scope 1 emissions are direct emissions from the organization. So if a company burns something on its campus, if there are emissions coming out of factories, for example, those are all classified into scope 1 emissions and direct emissions of an organization or of any entity. And then scope 2 emissions are emissions that occur due to the energy that an organization consumes. So these are also directly controllable because an organization can choose to consume one form of energy or the other, clean versus conventional energy, or consume less energy. So that too is directly under somebody's control, but it is occurring at the place where the energy is generated. So that's classified into scope 2 emissions. Everything else, including upstream and downstream supply chain, the emissions that occur due to employee commuting or business travel, all of that is classified under scope 3 emissions. And they are all said to be indirect emissions because it occurs in the supply chain or occurs because our suppliers emitted those carbon emissions in down or upstream supply chain. And it's important to look at this framework for scope 1, scope 2, scope 3 emissions because it gives us a good way to classify and measure the carbon emissions of an organization, of any entity, for example, for that matter. This framework was developed by the GHG protocol and is widely used in all of the reporting frameworks that we currently have And they also include even the government regulations that include CSRD, or the way in which the US SEC has been proposing how organizations should be measuring their carbon emissions and report them. So this is the definition of scope 1, 2, 3 emissions, which we'll talk about quite frequently now, even in our conversation.
I think I was on mute. So sorry. Yeah, thank you very much for very comprehensive explanation of the state of the system. So one of the things that you touched on was the amount of energy that the software systems are using. And I was reading something interesting the other day that was about the amount of energy that producing semiconductors is actually using. We usually talk about the amount of energy that the data centers are using, and as you said, it's estimated to be something between 1 to 4% of the energy produced in the world. But there's something around 1 to 2% of the energy that is produced in the world is being used for generating just the semiconductors. Right? So it's a massive number as well. It's estimated that the amount of energy that by 2030 is going to be used for generating semiconductors is going to be as much as the energy that a country as big as Australia is using today. Or the amount of emissions, given that we are moving towards greener energy, given that the amount of carbon emissions that these semiconductor manufacturing is going to produce is going to be the same as the amount of carbon emissions as a country as big as Portugal is generating at the moment. But how do you see this trend? Do you think that it is going to continue? Do you think that it is plateauing? How do you see the trend of energy usage in general in the IT industry?
It's a great point, Behrad. A lot of indicators in the market at this time lead us to think that the energy consumption of IT will grow, but there are more nuances to that. When we look at the consumption of energy by data centers over the past decade, it has been more or less flat despite the fact that data center workloads have increased exponentially. So we've seen more and more penetration in the telecommunication sector, more SaaS applications come into the market, and the movement towards the SaaS model by even traditional software vendors, all of which indicated that there has been a steady rise in cloud and public cloud consumption. And we would think that there would be a proportionate increase in the consumption of energy by all of these data centers that host these applications. But that's not been the case. It has actually been somewhat flat. And that's because of all of the innovations that has happened in the data center industry. We've seen a lot of passive and active sustainability related optimization in the data centers. As an example, passive optimizations include actually physically geolocating a data center in an area where those data centers can rely on its environment for cooling purposes. For example, moving towards the Nordics or closer towards the poles where there is cooler atmosphere just available, rather than relying on air conditioning for cooling these data centers to achieve a good power usage effectiveness internally. Then there are active measures that we have seen rise. For example, the use of artificial intelligence to monitor and anticipate the energy consumption data halls. And we've seen some research that has actually told us about substantial energy savings because of such measures. So because of all of this, and the optimization that has continuously occurred in the networking space and in data transmission, we've seen that the power consumption in the data center space has not increased, at least in proportion with the amount of workloads that has gone to the cloud, or the energy or the demand in data center services. However, a major trend that we will see now is the advent of specialized workloads, including artificial intelligence. And we all know about generative AI and the trends that it itself is creating in other parts of our workplace. So therefore, we'll see a lot more in applications that are very computing intensive. And at Forrester, we published a report which we titled Jekyll and Hyde, which looked at the both good and bad parts of emerging technologies, including artificial intelligence and other emerging trends that we see in the space in the market right now. And we looked at how some of these trends could aid in sustainability. As an example, the AI energy modeling that we can do within data halls that I just talked about. And on the other hand, the energy consumption that is caused because of AI. So how do we balance that? This balance, I think, will be a major trend that we'll see going forward, and more innovation that we will need in the space for tipping the balance towards being more efficient and more optimized will be something that we'll see more and more of, and more investments will come forward for the space, and more discussions will occur around the balance between how AI or other emerging technologies will either aid or hinder sustainability activities in the space. So we'll generally see more demand for energy by IT, as we actually will see more digital transformation efforts globally. But at the same time, I think we'll see more innovation happening so that we can balance that curve as much as possible.
Yeah, thank you very much. And in your survey, you look at the state of reporting at the moment in the industry. So can you explain a little bit about that, how's the state of reporting, how companies are actually trying to report their emissions, what they are doing, what are the trends there, and what do you see in the future of these activities?
It's a great point. In fact, sustainability reporting we found in our survey is mainly driven due to compliance at this time. So if we looked at it as if it is a carrots and sticks approach, sticks seem to be driving a lot of sustainability reporting, and we are seeing evidence of this globally, where when we see the advent of more compliance and regulatory pressure for organizations to report their scope 1, 2, 3 emissions and beyond, not just their carbon emissions, but overall their ESG metrics. So one interesting development is CSRD in Europe, where public companies need to report into in CSRD the various ESG metrics that they are now mandated to measure and report against. And we're also seeing that some of the challenges in the space are in rightfully measuring scope 3 emissions. So we talked about how scope 1 and 2 are direct emissions of an organization, and scope 3 emissions are indirect emissions. So for an organization in the financial services space, for example, data centers form the majority of their scope 1 and scope 2 emissions. This also means that it may be easier to actually measure those and report it than scope 3 emissions, which should involve collecting data from multiple suppliers, penetrating deep into your supply chain. And this has been a major challenge across the industry. And we found that in our survey as well, that scope 1, 2 emissions and related double clicks into those, for example, air and water quality monitoring, those were aspects, metrics that were measured and reported much more than scope 3 emissions. And then in terms of frameworks, we found that government mandates and reporting compliance related activity around the globe is actually driving more reporting, and not just in the public sector, but private sector actually needing to catch up with their counterparts in the public sector, simply because then this leads to more visibility amongst clients. And we're seeing this as an increasing trend, how organizations are considering sustainability reporting as a differentiating factor within the industry as well. So the government related compliance issues and regulations actually drive a lot of the first steps in terms of how an organization should measure their scope 1, 2, 3 emissions and set internal processes for measuring and reporting. But at the same time, then using that as a baseline, organizations are setting targets and really sending the message out to their customers and clients that they're doing their part to be responsible for the environment. So we are seeing an increased trend where the importance of sustainability will continue to grow.
Yeah, makes sense. And I also think, there's another problem with reporting scope 3 emissions, and is that, scope 3 emissions of this company is the scope 1 or 2 of another company. So it's very easy to double report them or triple report them, if you will. So yeah, scope 3 is very difficult, but reporting is still something that companies should try doing, because you can always just offload everything that you do to someone else and just forget about that. There are some complications in that, but I think it is something that we still need to aspire to do, which I think you agree that most companies at the moment are not doing. Am I right?
Yeah. That's right.
Yeah.
And most reporting frameworks also mandated the research and collection of metrics around scope 1 and 2 emissions, but not quite scope 3 emissions so far. But we are seeing more and more of that come forward. And there is also the problem of lacking standards in the space. Exactly like you pointed out, Behrad, somebody's scope 1 or 2 emissions becomes the scope 3 emissions down the supply chain. So for example, if we are talking about an end user device that an organization uses, the manufacturer of that device or the embodied carbon that's associated with the manufacture of that device is the scope 1 or 2 emissions of the manufacturer or the vendor who manufactures that device, but it becomes a scope 3 emissions as it comes through the supply chain and is being used in the organization of the client who purchases that device and starts using it. So these are all aspects that are very hard to measure so far, but at the same time, there is more research and best practices that are being discussed, and we'll hopefully see more organizations measure and report these types of metrics as well, which will be very crucial for us to then think about reduction in carbon emissions across the value chain.
Yeah, that's very good. So one thing that I wanted to talk about was the the efficiency of software and the effective efficiency of software and reducing the emissions. And for that, I want to basically look, a little bit back in the history of computing, because that's helpful. If you look at, from the beginning of the computing till around 2005, we spend everything that we have on making more efficient software, right? It was, efficiency is the most important thing. Everybody's trying to make things more efficient because firstly, our CPUs were not fast enough. So if you could make something more efficient, it was running faster. Also, we didn't really have a scalability. If you could do something faster, your CPU could do more things. But around 2005, with advent of internet and, internet scale companies, that efficiency wasn't that useful anymore, right? So we started to care less about efficiency, and basically the talk of the market has started to become a scalability. So we started focusing on a scalability instead of efficiency. And it was right, because, it didn't matter how efficient your software was. Without a scalability, you couldn't make Google, you couldn't make Yahoo, you couldn't make any of these big internet companies that we know today. So we started focusing on this scalability, and it kind of forgot about efficiency. But one thing that is important is that, yes, scalability is a great thing, because if you have a workload today that you can handle it with this software, if for whatever reason 6 months later this workload is doubled, you can just double the amount of hardware that you have, and then this is a scalable platform that you have is going to handle that workload. So that's great, right? So your business would never stop. But there's something that nobody usually think about, and is that if you have a software that is 50% more efficient, right? You can do that same thing, that, you know, the double amount of workload with the same amount of hardware. So you don't need to increase the amount of hardware that you require if you choose to use more efficient software, right? Then the next question becomes this, that, okay, yeah, I agree that more efficient software can be that much more efficient, but do we really have software that is 50% more efficient? And the answer to that is yes. You know, the algorithms are not changed, right? You know, most of the algorithms that we use today are still the same algorithms that we designed in possibly 70s and 80s, right? There's nothing new, but there's been a seismic shift in the amount of hardware that we have in different parts of the computer other than the CPU. You know, for example, the amount of RAM that you get on a modern machine, right, can be up to 24 terabyte on a single, you know, server, right? Back in the day, if you go like 10 years ago, a little bit more, 18 years ago, the maximum amount of RAM you could have on a single machine was 64 gigabytes, right? That's around 350 times difference. And the speed of RAM since then has increased around 10 times as well. So you can utilize the modern hardware in a different way to produce more efficient software, right? And well, Aerospike is basically using these changes in the hardware industry to produce a more efficient software. And I did a research last year, which I wanted to discuss the result of it in this talk as well. So, you know, as I said at the beginning of the talk, I used to work for a company which is producing most of the code in Apache Cassandra, and I used Apache Cassandra for a number of years before joining that company as well. So I know Apache Cassandra, if not better than Aerospike, at least as good as Aerospike. So one thing that I noticed as soon as I joined Aerospike was that this system is much more efficient than Cassandra. And I decided to basically do a comparison between the efficiency of these two systems. And what's better than, you know, comparing the efficiency in terms of CO2 emissions? So the paradigm is relatively simple. I chose a specific amount of data that I want to store on Cassandra, and a specific amount, that same specific amount on Aerospike. And then I said, okay, how much resources do I need to handle this much data on Aerospike, and how much resources I need to handle this much data in Cassandra? And then I calculated the amount of emissions that these resources generate, both in terms of energy usage and the amount of energy that was used for producing these hardware resources. And the final result was around 80%. So you can reduce the amount of emissions by moving from a less efficient software to a more efficient software by 80%. And this 80%, you know, the silver lining here is that you're basically reducing the size of your infrastructure by 80%. That's why you are reducing your emissions by 80%. Right? It's just directly, you know, even if I didn't do the math to calculate the exact tonnage of the CO2 emissions, you should be able to say that because the amount of resources is reduced by 80%. So when you reduce the amount of your resources, it becomes cheaper as well, right? It's not only, you know, you are reducing your CO2 because now your infrastructure footprint is smaller, you are going to spend less money. And then efficiency also means faster. So you expect that everything be 80% faster as well, which, I mean, is a pretty good thing. So yeah, you know, there are many different things, many different reasons that people should look at, you know, using more efficient software as one of the ways that they can reduce their CO2 emissions. Because 80%, I don't really think that there are an easy way that you can reduce 80% of CO2 emissions of a, you know, data center. You know, we are talking about smaller margins there because we, you know, thought about that a lot and we try to optimize that a lot. This side is something that we haven't thought about. And I think that as we are moving forward, as, you know, the size of the data doubles every now and then, and we need to basically increase the amount of hardware that we need. That's the type of innovation that we need to think about.
You're absolutely right, Behrad, in pointing out that as the amount of data in the world increases, we have to be thinking about scaling and efficiency in software. And we talked about earlier in how in the IT stack, the emissions come from three major areas. One is IT, data centers, and cloud. Then the other is IT in the workplace. And then the third part is about software and applications development. And all of this work that you've been talking about, your research, covers that software part and how to make it more efficient. And there are several debates here, like you rightly pointed out. For example, faster more efficient versus optimized, and all of those types of um, debates on how do we reduce the amount of man hours in software development. Will that lead to more efficient software, or will that lead to less carbon emissions throughout? And these are really interesting frameworks to think about. One of the things that uh, I had come across and had been working closely with some clients on is to understand the right refresh cycles of infrastructure. So what constitutes that decision? Now, when we think about whether we should be upgrading any infrastructure, to take a vivid example, let's say a server within the data center, then how do we make that decision on whether upgrading that server today versus 1 year from now will give us any benefits in terms of carbon emissions? So things that we should consider are about how efficient the new how efficient the new server would be, but at the same time, what would be the embodied carbon that comes with manufacturing of a new server? Then what about disposal of our older legacy infrastructure? What would be the carbon and ecological effects of that? And then the supply chain of bringing the manufactured new efficient server to our premises and taking the legacy infrastructure off of the premises. So all of those things combined makes the argument for whether replacing or upgrading infrastructure today versus amortizing the carbon footprint of that infrastructure for 1 more year will give us any more or less benefit. So it's very interesting, and I'd love to hear more about any more real world examples that you have as well, Behrad, that backs your research.
Yeah, that's a good point. Actually, we do have two publicly available use cases that I can talk about. So one of our customers is a company called Critel. They are one of the biggest ad tech companies in the world. They're the largest in Europe. They migrated from some other database technologies to Aerospike 3 years ago, if I'm right. Yeah, it's 3 years ago. And in the report that they published, they mentioned that one of the reasons that they did that was basically reducing their CO2 emissions. And in that report, they mentioned around 80%, which again, very similar to the number that I produced. But we have something that is even newer than that, and that one was even more surprising. So another customer that we acquired in the last few months actually is the famous company TomTom, the navigation system that you possibly still remember. They're still around and they are doing lots of things in the background. You don't have the devices anymore, but possibly your cars are still connected to their systems in the background. They are doing mappings and navigation for lots of the largest car manufacturing companies. So they were using another caching technology actually, and they decided that instead of using that caching technology, they want to use Aerospike, which is a database, but the speed of Aerospike is very similar to caching technologies. As I said, it's so fast that, instead of using cache, you can just use the database and it will be as fast as the cache. And well, of course, it uses much fewer resources and it's going to end up being a lot cheaper because, well, keeping everything in RAM is very expensive in comparison to keeping everything on disk. So they moved from the caching technology into Aerospike, and they've been on the technology for like 5-6 months. So they reported lots of positive things. So for example, they said that the number of outages that they had was reduced from, I don't know, 6 outages every 2 weeks to 0 in the past 6 months. So that's already good. But one thing that is relevant to this topic is that they reduced the amount of their CO2 emissions by 86%. So they and it is important because firstly, it says that companies actually do care, in their public announcement of moving to this technology. They mentioned the amount of CO2 emissions that they could reduce, and we didn't ask them to do that. So they mentioned that one of the reasons that they moved is reducing the emissions, and they calculated the amount of emissions that they could reduce. And again, it was basically by reducing the number of surveys that they require. They used to have, if I remember correctly, 49 surveys or 48 surveys. They reduced it to 3, basically.
Oh, very interesting, Behrad. That leads me to think.
Topic that I said about, reduce the amount of resources. Go ahead.
Sorry to interrupt, Behrad. Please go on.
Yeah. So I was just saying that. Yeah. So I was just saying that they could basically reduce the amount of emissions by that. So it's been very, very interesting. So as we are closing to the end of the hour, the 45 minutes that we want to have this. I want to ask you a final question. So how do you think companies can create a sustainability strategy for themselves so they can reduce their emissions, plan it and get there and be able to report good numbers because now, as you said, a lot of legislations are asking companies to report that, and I think nobody wants to be in the bad name, right? Everybody wants to report good numbers. So how companies can reduce their CO2 emissions moving forward?
Well, developing a good IT sustainability strategy really begins with understanding the IT estate of your organization and looking at where emissions come from, and then creating a map of what are some of the most important and impactful decarbonization levers versus what are most pragmatic. As an example, we talked about how scope 2 emissions is about energy consumption. Data centers consume a lot of energy, but it may not be possible for many organizations to really switch to green energy in many regions that they operate in. On the other hand, our strategies associated with end user devices and circular economy that may or may not be possible or may have more or less impact compared to some of the other investments that they could make in the IT sustainability and decarbonization efforts that they would make. So in our research, we found that the most successful strategies involve creating a framework for thought and then creating an analysis of the most impactful decarbonization levers versus the most pragmatic. And when we think about the decarbonization levers, in fact, it's vivid from the examples that you gave also, Behrad, about the thought process of looking at where emissions come from. So ITs, so hardware and data centers is one big bucket. Then, like we mentioned, the end user devices in IT in the workplace is another. And the third aspect is about software development and application sustainability. And one of the trends that we are seeing now is about how difficult it is to actually measure the carbon footprint of applications itself. But there are more processes and standardization that are happening. And for example, we are seeing more and more best practices in software development, as well as using proxies such as measuring the optimization in cloud workloads to understand how much data or how much carbon emissions actually come from cloud workloads itself. So those are some of the key aspects of creating an IT sustainability strategy. First, to look at an end-to-end in enterprise architecture decarbonization strategy in terms of where emissions come from and grouped into these different buckets that we talked about, and then creating a list of some of the most impactful decarbonization levers versus the most pragmatic, and then creating more processes associated with that in terms of what types of metrics and KPIs can you measure, and how do you then optimize on those KPIs and metrics? I'm curious to hear your thoughts as well, Behrad, on like how the software industry can itself enable more decision makers to make better decisions regarding IT emissions.
Well, I think the first step in doing any engineering work is having a framework to measure the impact of the decisions that you make. I mean, it's a very common thing for a software designer to look at some non-functional requirements when they are choosing different technologies that they want to use. So non-functional requirements are, I don't know, for example, the SLA, how fast you want this system to be, right? Or I don't know, what is the cost of this system should end up. These are not necessarily defining the functionality of the system. They are talking about, the expectation that you will have from the system. So I think one of the non-functional requirements that people should pay attention to is the amount of CO2 emissions that the software platform is going to generate. To have that, you have to have basically a framework to basically can look at and say that, okay, if I use that technology, it's going to have these, I don't know, outputs, and it's going to generate this much CO2 emission. And if I use the other one, it's going to have these characteristics and that much CO2 emissions. And that should become part of the conversation when you are choosing which technology you want to use. And for this, we need some standardization. I think, I don't know, very similar to when you buy a refrigerator, for example, it has a sticker that says that it uses, I don't know, energy level A or B or C. Software can have something like that as well. I don't know, I'm just thinking out of the box that, different technologies could get standards for amount of resources that they require. I think that could be a step forward that allow people to allow decision makers to make more informed decisions, because at the moment nobody talks about this. You just say that I want a streaming technology, and you just pick the streaming technology that is the best for your budget and fulfill your other requirements, not the requirements related to CO2 emissions. So the conversation is very interesting, and I wish we could continue, but we are already at the top of the 45 minutes. Thanks everybody who joined and listened. And if there's nothing more, I want to say goodbye. And Abhijit, if you have anything else to say, please go ahead.
Well, thanks everyone for joining, and this was a very interesting discussion. And Behrad's research on software sustainability is really crucial because of the way in which we should be thinking more about standardization and measuring how software can be made more sustainable, and looking into the ways in which software can be made more efficient in itself, and how the software industry can overall become more sustainable. So those are really interesting outcomes that we discussed, and was great to hear from you, Behrad. So thank you very much, everyone, for joining, and hopefully there were some great takeaways, and always happy to answer more questions too.
Thanks everybody, and good to see you. Goodbye.